Hi friends, in this tutorial we are going to write a linked list implementation from scratch. So let's get started. First we need to include the header files stdio.h and include stdlib.h. This is for including the malloc. Then let us write main. Before that, the linked list implementation, it will contain node, series of nodes connected with each other through links. So let us define the structure of the node first. This will be node. And currently I am doing implementation where the payload will be integer kind of data, and later it can be generalized. So this is nothing but payload, and there should be a link for the next node. So we define it as next, and this is a singly linked list. So we can traverse only in the forward direction and not the reverse direction. Every time we don't want to write the whole structure name, for that we can use type def. So we can write it like this: type def struct node and node. Similarly, we need to define header, a pointer to the starting of the linked list, which we will call list head. So let us try to declare structure for that. It will be list head, and it will contain only one pointer of type node to the we can call it head, and this should be pointing to starting of the list, linked list. This also we can type def, so that next time while declaring variables we can use struct. So next time I can directly use only list while declaring variable and node here. So now these are the structures of the node and list. So how we are going to use it in main? We want to create one list, let's say L1. We would like to initialize its head. So for that I can write one function initialize list, and we can pass L1 to it. After which we would like insert, delete and display. These will be our methods which we can use on our list. So insert will be of like L1 comma element 10. Similarly, we would like to insert multiple elements. Let's say this is 20, 30, 40, 50 and 60. Once the insertion is done, we would like to see the contents of the list. So for that we can write display function. Then we would like to delete some elements from the list. Let's say delete 30, and after deletion we would again like to display the list. Similarly, we would like to delete elements at the beginning and the end to make sure that our logic takes care of all the edge cases. So here it will be 10, and one more can be 60. That is the last element in the list. Now that we have written how the operations we want to perform on our linked list, let us try to implement them. So we have functions insert, which will take argument list star list, int data, which we want to insert, and currently return is of type void. Similarly, I want to implement delete and display. We would first implement insert and display, and later on delete. Display doesn't require data argument. We just have to pass the list which we want to display. So let's get started with insert. We also want to write one helper function for creating the node, which will return us pointer to the node created. So this is create node function, and it will take argument what data needs to be stored in the list. And node star temp is equal to malloc, the size of memory, how much we want to allocate, that is nothing but size of node we want to allocate, and we want to typecast it to node star. And once the memory is allocated, we check that it is not null. If it is null, then we would just throw error saying malloc failure, and from here we can just return, we have to return null. Once the malloc is successful, then we need to store the data in the node, that is temp data is equal to data, and temp next we'll have to initialize to null and return temp. So this returns the address of the node which we have created. Sorry, this is tmp temp. So this is our helper function create node. Let us now write the insert function. So first we need to check if list is empty. Before that, we need to write one more function which I forgot, that is nothing but initialize list, which initializes the list header to null. Let me go at the beginning and write it. Argument list star L1, and here we have to do, we can call this variable list, and here we just have to do list head equal to null. That's all initialize list will do. Now let's get started with the insert function. First we need to check if list is empty. So if list head is empty, this is the first node we are going to insert. So here list head should point to create node and data which we want to pass. So create node will create a new node, and list head will point to that node, and from here we can just return. This is the case if this is the first node insertion into the list. Otherwise, if list already exists, then we need to reach the end of the list and insert the element node there. So for that traversal, we can create one pointer which will point to list head, and we need to traverse to the end of the list. If ptr next while ptr next is not equal to null, we will keep on traversing. Ptr will be equal to ptr next, so it will keep moving to the next node till the end of the list is reached. So once the end of the list is reached, we can come out here. So let me just write some comment. Insertion of the first node or data. Then here we are traversing to the end of the list for insertion. So here we have reached the end of the list. Now we need to ptr next will be equal to create node, and we need to pass the data. So this will do the insertion for us. Now that insertion is done, insertion of the data is done. Now let us try to write the display function. So for display, again we need to check if list is not null. If list is null, we have to display error. Or just a message saying list is empty. and just return. If list is not empty, then we need to display. Again, we will use a pointer to traverse the list. Initially, it will point to list head, means the first node in the list. Then we need to traverse till the end of the list. So while ptr is not equal to null, we just have to traverse and display printf %d new line and data is ptr next. Oh, sorry, ptr data. So this will print the data in the node, and after which we need to move to the next node. So ptr is equal to ptr next. So this way we will reach till the end of the list and will display all the elements in the list. So let us try to quickly run the program and see. Before that, let me comment out all the delete calls, delete function calls. Let me name it linked list, and compilation is successful. Let me just run the program, and it has printed 10, 20, 30, 40, 50, 60. It has printed 2 times. So why that? I think I have not saved after commenting. Let me just save and recompile it once more, because it has printed, I think, 2, 3, 4 times. Let me rebuild the program. Let me clear the terminal and execute. Yeah, so as we can see, all the elements of the list have been printed. Now let us try to write the delete function. And let me uncomment it, and let me comment these remaining delete and display. So for delete also, we have to consider 3 things, 3 cases basically. If the list is empty. Second case is if we want to delete the first element in the list or the last element in the list. Deleting from empty list, or we can say checking if list is empty. Check if list is empty. In that case, we will throw error. First element deletion is not a special case, but only element in the list. If there is only one element in the list, that's a special case, because we need to again reinitialize list head to null in that case. I will say delete element somewhere in between, and fourth case can be deleting the last element of the list. So let's try to take care of these conditions. So if list head is empty, then we just throw error saying list empty and return. Deleting first element in the list. Then let us write a pointer which we will use to traverse, and it is pointing to a first element in the list. And if we check if this data in the first node is equal to the data which we want to delete. If that is the case, then we move the list head. List head should move to the next, current, next, and we delete the node which we are pointing with current. So this will delete the first element in the list and will move the head of the list to the next node. If it is not the first element which we want to delete, then we need to reach the node which we want to delete. So for deletion, there are two ways possible. One is to use current pointer and previous pointer, where we move both the pointers to the next nodes, and when current reaches the element which we want to delete, then we use the previous pointer to point link to the next of the current. In this case, there are two pointers used. The other way is to use a single pointer, and we check the data using the next pointer. I'll be using the second method, where we use only one pointer to check if we have reached the node which we want to delete. So let's write while current point next points data, if equal to data, then we want to delete that node. But yeah, so node, I'll use node start emp, which will point to the current points next. This temp pointer, I'll use it to free, but before that I need to update. So now temp is holding the pointer to the node which we want to delete. So let us relink the current next to the next element by passing the node to be deleted. So for that, we'll have to write current next will be equal to current next, and we will free the node pointed by temp. But in this case, we always need to take care that current next is not null. So this condition says current next is not null, and current next data, if equal to data, then only we delete the element. So this implementation was basically deleting elements somewhere in the list. So I'll copy paste that comment here, and let us now try to run and see if it works. A delete function works fine. Before that, in display, I would like to add one print statement just to show this is new list. The list is, and then that's all. Now let us compile and run the program. So initially the list was 10, 20, 30, 40, 50, 60, and next time also it is the same. So deletion has not worked. Or which element we tried to delete? Let me see. We tried to delete 30. So there was error in the code. So here we are trying to directly compare if data is equal to the node which we want to delete, and we are just if this is not the case, then our while loop will not be satisfied, while condition will not be satisfied, and will come out, and hence the list remains as it is. So what we will do, first we will try to traverse and reach the node which we want to delete. So for that we will just do next. Whenever this condition is not true, that is, then we will do current equal to current points next. Once we come out of this loop, we can come out for two reasons. One, current next is null, or we have reached the node which we want to delete. So here we will check if current next is not null. Then we will do the deletion. And this is, yeah, this is required anyways. Temp will use to delete the element, and current next will be equal to, yeah, so the node which we want to delete is nothing but current next. We want to, temp will point to it, and temp we can delete, and current next we need to update it to current next. So yeah, this looks good. So let me try to compile the program and see if things work fine. Let me clear the terminal. If I see the list here, 20 got deleted instead of 30. So let us see what's the problem. So let me check the condition, what's wrong here. So while current next is not null and current next data is not equal to data, till that we need to move forward. Okay, now let me check. Yeah, now if I see the output, it is as expected. It has deleted node 30. Now let us uncomment the remaining delete statements and see if it works fine. So next we are deleting 10 and 60 as well. Let me increase the size. So yeah, compiled. Now execute. Okay. Deletion of the, I think 30 deletion was successful. After that, it has given segmentation fault. So we have tried to delete 10. So let's see what's the issue there. So here we are checking if it is empty. No. If this is the first element we want to return, then after deleting, we want to return. Yeah, let us try to execute now and see. Yeah, let me check. So here 30 has been deleted. This is the original list. Here 30 deleted. In next 10 has been deleted, and the last iteration 60 has been deleted. So yeah, looks like all the functions are working fine. So this is how we implement singly linked list for integer kind of data structure. So in this tutorial, I try to give a general idea of how integer payload linked list can be implemented. So this is only singly linked list, means forward direction we can store the data. There is also possibility of a doubly linked list where you have two pointers, one pointing forward, other pointing backwards. In that case, traversal becomes easy, which we can discuss maybe in the next tutorial. For now, that is the implementation of singly linked list. Happy coding. Bye for now. Thanks for your time.